Jai Hind to all. I, Chelsi, Assistant Professor in IT Department working in the AKGEC Ghaziabad. Today we will discuss about the topic RSA algorithm. RSA algorithm in the computer system security. As you know that the RSA algorithm is used in the asymmetric cryptography. Just first discuss about the contents, what we are going to discuss about the particular terms. First we will be discussing about the introduction, RSA algorithm, what is the RSA algorithm, and what are the steps in the RSA algorithm. Then we will discuss about through an example. We will take one example, mathematical problem. Through that we will solve that particular problem. Then we will discuss about the advantages of the RSA algorithm. Just go through the introduction. In introduction, RSA algorithm is a basic example of asymmetric cryptography that we have discussed already in the previous lecture, that what is the asymmetric cryptography. Asymmetric cryptography is called as a public key algorithm in which we are using various encryption, decryption techniques. And in that particular asymmetric cryptography, we are having the two particular keys, that is public key and the private key. So there was the advantages of asymmetric cryptography was better key management. Means in that particular cryptography algorithm, we was having a better key management. We are generating the public key, we are generating the private key, and according to that only we are transferring our data. There are various disadvantages of the asymmetric cryptography also. It was very slower and more complex because in this we have to compute many computational examples over there. So in this, the best example of asymmetric cryptography is RSA. RSA algorithm in which we are going to compute the various encryption and the decryption techniques. Means whatever we are using, whatever message we are transferring from one place to another, how it can be transmitting through by applying the encryption and the decryption. And we are generating the various key algorithms. Okay, how we can generate the keys, public key, private keys. They are the various example of the asymmetric cryptography also, that is Diffie-Hellman and EI-Gamel. We will discuss it later, but one of the most important algorithm which is RSA in the asymmetric cryptography. Let's discuss about that. In asymmetric cryptography, we are using the private keys and the public keys. We are using private keys as a decrypting thing and public keys for the encrypting things. In asymmetric cryptography, we are using two keys. That's why it is called as asymmetric. In the symmetric case, we are using only the one key, that was a public key. So over here, we are using the two keys. For the decrypting, we are using the private keys, and for encrypting, we are using the public key. So let's discuss about the things where it can be used. As we know that we are having a various cryptographic algorithms. Over there, we have discussed about the three algorithms. First one was the symmetric cryptography algorithm. Second was asymmetric cryptography algorithm. And third one was the hash function. This is the basic introduction where we can use our RSA algorithm. That's why we are discussing all these things. So just go through the one by one thing, that what is the asymmetric cryptography, then symmetric cryptography, and where the hash function used. Just discuss about the secret key symmetric cryptography. In this, what we do, whenever we transfer any message or any plain text, in that we are converting the particular term into the ciphertext. We have discussed about the term plain text. Plain text means any message we want to send. Okay, whenever we are sending any message, it is into the normal form. For example, we are sending it is a hello. Hello is a message we are going to transfer to the sender to the receiver. So over here, what we are using, sender is sending a message hello, which is in the plain text, which is going to convert into the ciphertext using some key. Okay, then it is converted into the unreadable format. What is ciphertext? It is where the message is converted into the unreadable format. So is this hello will convert it into a particular terminology through an algorithm. So this algorithm, how the message is converted. So this is only the particular term where we are using the encryption and decryption using the RSA algorithm. Now, for example, hello got converted into some values. For example, 30, 40, sorry, it can be a 31 or any numeric digit it got converted. Now, what is the next step? We are again transferring this ciphertext into the plain text. So it will got converted again into a message. Means whatever we are transferring as in the first, we got as the last. Over here, what we are doing, only single key. Same key we are using over here. So this is called as the symmetric cryptography. Means over here for the encryption we are using the same key, and for the decryption also we are using the same key. Whenever we are using a single key for the encryption and decryption, this process is called as symmetric cryptography. Got the thing? Now let's discuss about the next thing. Why we are discussing these things, this cryptography algorithms, types of this algorithm? Because for the encryption and decryption, we are going to use some algorithms, and that algorithm is RSA algorithm. That's why just discussing about the things, how we can convert the encryption and decryption things. So next process is where we can use our encryption and decryption things in the asymmetric cryptography, where we are using the two different keys for transferring our messages into the particular ciphertext. For the encryption, we are using a different key. For example, it is a public key, and for the decryption, we are using a private key. Okay, so for the encryption and for the decryption, we are using the two different keys in the asymmetric cryptography. And with the help of RSA algorithm, we can convert these encryption values and decryption value into the particular format. Okay, got the terms? Now, next thing is hash function. Hash function, in this what we are doing, we are just converting the particular plain text into the ciphertext, but it is a one-way process. How it is a one-way process? Means if we have converted our plain text into the ciphertext, then it won't be converted into the into the plain text. Means it is only a one-way communication. In that, your input got changes into the particular output, but from output you can't get the input. This is the only thing which we can do in the hash function. So it is a one-way cryptography. Hash functions have no key. Means in this we are not using any keys. In this we are using any values, from that we are finding particular terms. So these are the things. For that we are using the RSA algorithm. We will discuss about the RSA algorithm. Before that, you should know about that thing, where we can use the RSA algorithm. Now, in the digital signature also, you can use the RSA algorithm, because over here also what you are using, it is a type of a public key encryption only, that we have discussed in the previous lecture also, that what is the digital signature. Okay, so digital signature is also used for the public key encryption and decryption only, where we are transferring the message into a sender to the receiver, and along with that we are transferring one message also. So we are using over there also, we are using the encryption and decryption, and for that we need some keys, public key, private key. So these key generation will be along how we can generate these keys, will be helping in out your in the RSA algorithm. So just discuss, this is the process of digital signature, where we are sending one message. Along with that, we are sending some signature, and how we can generate the signature using some keys. Like here we are using some private keys, and from that we are using some signature, and that combination of message and signature are transferring to the recipient. Okay, sender is sending the message, along with that sender is sending the signature also. Okay, so a signature is generated from private key. So how we are generating the keys will be used in the RSA algorithm. So these are the advantages or the application, we can say, of the RSA algorithm. We can use the RSA algorithm, the digital signature process, asymmetric cryptography, public key cryptography, or where the encryption or decryption things are generated. So these are the various things which are used over the RSA algorithm. Now, for the generation, for this transferring the message, we have generated the message plus signature. Now, recipient will also again decrypt the things, and decryption will be done by using some keys. So again we are generating some decryption values using some keys. So over here we are using public key. So what we are doing, we are generating some public key, private key, encryption and decryption. All these processes are going to be done, and how these processes are going to be done, this will be understood by the various algorithms. And one of the best algorithm is RSA algorithm. Just now discuss about the RSA algorithm. So RSA algorithm is developed by Ron Rivest, Adi Shamir, and Len Edelman. Okay, so how the RSA name is got, how we have acronym the word RSA. It the name is given on the basis of their developer's name. What was the developer's name? Ron Rivest, Adi Shamir, and Leonard Edelman. They have taken the name of, they have taken the surname acronym of that particular person. R for Rivest, S for Samir, and A for Edelman. So this how they had given the name of an algorithm. They have sorry, they have generated one public key signature algorithm. They have generated one signature algorithm in which they had given the names through their surnames. Surnames acronyms, first name of their surname, like R for the Rivest, S for Samir, and A for Edelman. This is how the name of the algorithm is given, and this was given in the 1977, and they have published one paper on that. They have given that how we can generate the public key, how we can generate the private key, and how we can do the encryption and decryption in this following process. Okay, so RSA, what RSA can do? RSA can also encrypt and decrypt the general information. Means whatever data you are sending, whatever information you are sending, whatever the data exchange of data is doing, so it can be handled by RSA algorithm. So RSA can helping in using the encryption and the decryption of information in the data exchange. Whatever the data exchange we are doing, it can handle the digital signature verification. Means how you can verify the particular person. This, along with this, you can handle the verification also. This is the overall process of transferring a data, in which we are transferring message, then we are converting some values into the hash value. Using that, using some keys, we are applying one encryption so that our messages got converted into the ciphertext. Okay, then again what we are doing, we are converting our messages or our ciphertext into a decryption, so that using some public key, we are decrypting the particular term again into a particular thing. So these comparison is done under the RSA algorithm, that whether our values are same or not, whether the message is sent over here was same at the receiver end or not. These we have to check. Now we will understand what are the steps, in that particular algorithm, how we can generate the algorithm, generate the keys, particular keys. Just discuss about the thing. This is the overall algorithm in which we are supposing some numbers, then we are computing some particular things. This particular algorithm we are dividing into the two steps. For example, in this we have divided into two particular terms. First one is key generation. Means what we are doing, we are generating a key, because for the encryption and decryption, what we are using, public key and the private key. So first task is that we are generating a keys. Means how we get the particular values of a key. Using a key value only we can generate the particular terms. So we are generating some keys. For example, we are generating keys using for the encryption and the decryption. Okay. Next step is encryption and decryption functions. Means what's the value of encryption? After that, after using the particular key, how we can get the decryption value. Okay, so these are the steps for the encryption, the decryption function. Let's go through an example. These are the steps for the encryption and key generation. What you have to do, you have to choose any two numbers, any two large prime numbers, for example P and Q. So what you have to do, then you have to calculate n is equals to P into Q. For example, let's discuss with the example. This is the example. For example, what we have done, we have taken one example. We have to take the two prime numbers, large prime numbers, whatever the prime numbers you have to take. So let's suppose we have taken 3 and 11 as a prime number. Now, what is the second step? We have to do as n is equals to P minus 1 and multiplied by Q minus 1. So what we have taken, P as a 3 and Q as a 11. So what we have done? We have done P minus 1 is 3 minus 1 is 2 and Q minus 1, that is 11. 11 minus 1 is equals to 10. So what we have got the value? We got the value of n as a 20. Okay, let's suppose n we got. Now, what was the thing? This step we have done, we have chosen two prime number. Then we have calculated the n. We have to calculate the n, that was P into Q. and z is equals to p minus 1 and q minus 1. Got the things? We got the terms p minus 1 and q minus 1. Now, what is the next step? We have to choose any random number. We have to choose any random number which should be lie 1, that should be greater than 1, and it should be less than z. What was the value of our z? For example, I am just taking it again. 3 and 11 we have taken the example. Then we have calculated the value of z. That was 2 into 10. That was 20. So, what is my value? This is the z, okay. So, it should be greater than 1 and it should be less than 20. So, let's suppose I have taken, it should be 7. For example, I am taking, we can suppose, we can choose any number. You can choose any number in that case. So, let's suppose what we have done, we have chosen the 7 over here. Now, what we have to calculate? We have to calculate d. See, what we are doing over here, we are generating some public key and the private key. And what is the value of public key? Public key is denoted as n and d and n and e. Okay. So, for example, we are getting a private key as a n and d. And we already got the value of n. That is p into q. What was p? 3. And what was q? That is 11. So, this is the n value. What is the n value? That is 33. So, we already got the value of n. Now we have already supposed the value of e. What was that? It should be greater than 1 and it should be less than z. So, already we have discussed, we have supposed that our value will be 7. Now, what we have to calculate? We have to calculate d is equals to e minus 1 modulus p minus 1 and q minus 1. This is how we can calculate our d. So, what we have done? We have generated our public key and private key using this particular terms. Okay, now just calculate d is equals to what is the value of your e? That is 7 minus mod of p minus 1 was 2 and q minus 1 is 10. That is 20. What value we will got to get the term is d? How we will get the value? How we will consider the thing? So, what value will get as a d so that we can convert that we will get the remainder 1. So, for example, let's suppose if I will take 7 into 3, that is 21, and 21 mod 20. So, here what remainder I will got? That is 1. So, what the value we got? That is 3. Just discuss once again overall things. See, what was the thing? We have done the p and q large number of, we have selected the 2 prime numbers. Then we have calculated p into q. It was p and it was q. Then we have calculated z, that was p minus 1 and q minus 1. Okay, then we've got the 20 value. Then what we was needed? We was needed one term, that is e is equals to 7. That should be greater than 1 and less than z. So, we have supposed that is 7. Now, what value we will get to calculate d is 7 into 3 minus 1. Means, what was the value? Whatever the value was there, e into modulus 3 minus 1. So, exactly what we will get? We should get the remainder 1. So, how we can get the value remainder 1? By applying the value 3. So, now we got our public key and private key. How we have calculated d is equals to that? That is d is equals to particular terminology we have used, that was the e value, and we have to find the particular word in which mode we have to got the particular mode as a minus 1. Means what we got? हमें equal में 1 मिलना चाहिए. So, we got the term 321 minus 20, that is we got the remainder 1. So, how we got the value? D is equals to 3. And this is our public key and the private key. What was the public key? N and E, and N and D is our private key. So, we got the values of public key and the private key. This how we have calculated the public key and the private key. We have already generated the public key and the private key. Now, let's suppose how that was the second step ki how we can generate the encryption and the decryption. This is the particular generation of encryption and decryption in which you are using a plain text as a M. Any message you can say, message you are denoting as a M. Okay. Now ciphertext will be converted. Ciphertext means you are converting message into ciphertext. And what is this process? It is a encryption process. So how we can encrypt the thing? This is the particular thing. How you are doing? You are transferring message into ciphertext, and this process is called as a encryption. So you are calculating this ciphertext. You are having some message. For example, you are having some message and you are calculating from over here. You are calculating it from this. Ciphertext is equals to M E mod N. And already we are having a value of E. Already we are having a value of N. Okay. Similarly, we are using the ciphertext. If we got the ciphertext from over here, then again we can convert the into the plain text. Let's suppose through an example we can understand the things. Already we have generated some key values. This example only we will take. Okay. So sorry. For encryption we are doing. Let's suppose we are transferring one message that is 31. 31 I am transferring to a sender. This is the sender and this is the receiver. I am transferring some message that is 31 to the sender. Okay. Now what I am doing, I am transferring this message into the ciphertext. Means I am going to convert this value into particular this thing. And how I can convert this ciphertext? Let's calculate it by this. What was the formula? We are doing, let's suppose M is equal, it was this, M to the power E mod N. This was only the thing. That's how we can calculate the ciphertext. So what is the value of N? Let's suppose we have taken the message that is 31 that we have done. Okay. And we have taken the key value. That was, what was the key value? In the encryption we have taken, that is the public key, that was 7. That we have already calculated. So we have calculated M to the power 7 mod. What is the value of N? That we have calculated into P into Q. That we have done 11 into 3. That was the N value only. P into Q, that was 11 and 3. So that's how we have calculated the values. So how we will get the things? 31 to the power 7 mod 33. So what's the value we got in the ciphertext? That is C is equals to 4. Means what we are transferring the message 31 and it got converted into the 4. Now again we are doing, over here we have done the encryption. Now what we are going to apply? Decryption over here. And in decryption what we are going to do? We are going to convert ciphertext into again a message. If we are going to convert the same message, means whatever message 31 we have sent. 31 we have sent and again we have to receive the 31. If we got the value correct, then we have done the right process. So this is the decryption thing. And what we are going to do? Now from ciphertext we are going to calculate the message value. Okay. Now what we are going to do? We are going to calculate the value of message. We are having the ciphertext value. So we are going to convert over here. Means we are calculating the message value. For example, C. What was the value of C? That is, we have calculated C is equals to 4. So now just suppose 4. Now this is the D. D is for the decryption process that we have used for the key. Right? Decryption is used for the particular key that we have already generated. These two keys we have already generated. This was the private key and this was the public key. For the encryption we are using different key and for the decryption we are using the different key. So over here we are using a different key, that is D, and that's value was 3 to the power 3 and mod 33. So 4 to the power 3 is 64. 64 mod 33. This is again the value of N only. So whenever we are going to calculate, we have again received the value of M is equals to 31. So this is the overall process that initially we have sent one message that was 31 and at last final encryption and decryption we have, after applying encryption, after applying decryption, we are receiving the same values. Got the things? Now let's discuss about the advantages while we are using the RSA algorithm. That is, no need to sharing the secret keys. You are using two public keys. You can calculate that particular keys. You can generate the things and you can calculate. Now next is you can authenticate your particular owner's authenticity. You can do the faster encryption than the DSA. DSA is also one algorithm. Along with that, you can use the faster algorithm in comparison to the DSA. And the last advantage is that data can't be modified in the transit. In between, no one can transit your data in between. So this is the overall RSA algorithm, and these are the various advantages of the RSA algorithm. Thank you. Jai Hind.